The rover, called Perseverance, survived a perilous high-speed plunge through the Martian atmosphere and made it safely onto the surface of the red planet.
Space rovers are some of the coolest machines ever made. Think about it. These robots travel millions of miles, land on strange planets, and start exploring places no human has ever been. But how do they even work? Who builds them, and how do they survive in places with no air, freezing nights, and storms of dust? There's a whole team of brilliant people behind the scenes designing, testing, and building every part of these incredible machines. Stick around, and we'll break it all down. You won't believe what goes into making these high-tech explorers. Step 1. Defining the mission. Before building anything, the first step is figuring out what the rover needs to do. Scientists and engineers come together to decide, will it search for signs of life, study the planet's weather, collect rock samples? Every mission has a purpose, and that purpose shapes the rover's design. For example, NASA's Perseverance rover was built to search for ancient life and prepare samples for a future return to Earth. Once the goals are set, they decide what tools the rover will need. Cameras, drills, or maybe a laser to zap rocks and study their makeup. Every instrument has to be carefully chosen and tested to match the mission. At this stage, the team also plans how the rover will handle extreme conditions like dust storms, freezing nights, and intense radiation. It's like designing the ultimate survival kit for another planet. Step 2. Designing the rover. This is where creativity meets science. Engineers start by sketching out what the rover will look like. It needs to have a strong body, wheels that can handle rough terrain, and arms for digging or picking up rocks. Think of it like designing a car that can drive through the most dangerous place on Earth. Except this car has to work millions of miles away without anyone to fix it. The rover also has to carry all its tools and cameras, so every inch is planned out carefully. Designers use computer models to test how it will work in different situations. Will the wheels get stuck in soft soil? Can the solar panels collect enough energy? Every small detail is tested and adjusted because once the rover is on another planet, there's no turning back. Step 3. Building the rover. Now comes the exciting part, actually building it. The team starts assembling the parts, from the wheels and robotic arms to the cameras and scientific tools. Every piece is made with special materials to handle the harsh conditions of space. For example, the body of the rover is made of lightweight metals like aluminum to keep it strong but not too heavy. Each tool, like a drill or laser, is custom made for its mission. It's not just about putting things together. Every wire, circuit, and screw has to be placed perfectly. Even the rover's brain, its onboard computer, is designed to handle extreme temperatures and radiation. This stage can take years because there's no room for error. Step 4. Testing the rover. Testing is one of the most important steps, and it's also the most intense. Engineers put the rover through tests to make sure it can survive everything it might face. They use special chambers to simulate the freezing cold, intense heat, and vacuum of space. To test the wheels, they create fake Mars-like terrain with sand, rocks, and slopes. They even simulate dust storms to make sure the rover's instruments won't get clogged. Every tool and camera is tested to see if it works as planned. If something fails, they fix it and test again. This process can take years, but it's worth it because even a tiny problem could ruin the entire mission. Step 5. Launching the rover. Once the rover is ready, it's time for the big moment, launch day. The rover is carefully packed into a spacecraft, which will carry it to its destination. Launching a rover is one of the riskiest parts of the mission. The spacecraft has to break free from Earth's gravity, survive the intense vibration of liftoff, and travel millions of miles through space. Scientists and engineers monitor everything to make sure the rover is safe. The journey can take months or even years depending on how far the planet is. During this time, the team stays on high alert, tracking every detail to make sure the rover stays on course. Step 6. Landing on the planet. This is the most nerve-wracking part of the entire process. Landing a rover on another planet is incredibly hard, especially when it has to do it all by itself. For example, the landing sequence on Mars is called the 7 minutes of terror, because it happens so fast that there's no time to fix mistakes. The spacecraft carrying the rover has to slow down, use parachutes, and sometimes even rockets to land safely. Some rovers are even lowered to the surface using cables, like Perseverance was. Once it touches down, the team waits anxiously to get the first signal that the rover is safe and ready to explore. Step 7. Exploring the planet. Once the rover is on the surface, its real mission begins. It starts by taking pictures of its surroundings and sending them back to Earth. Then it uses its tools to study rocks, soil, and even the atmosphere. Some rovers, like Curiosity and Perseverance, have drills to collect samples and tiny labs to analyze them. Everything the rover discovers helps scientists learn more about the planet. It's like a detective solving a mystery millions of miles away. The rover also has to manage its energy, usually by recharging its batteries with solar panels. Every move is carefully planned by the team on Earth, but the rover also has some autonomy to make decisions when communication delays make it impossible to wait for commands. Step 8. Sending data back to Earth. The last step is all about communication. The rover sends everything it finds, pictures, data, and results, back to Earth using antennas and satellites. This information travels millions of miles, taking minutes or even hours to reach us. Once it arrives, scientists analyze it to understand more about the planet's history, geology, and potential for life. This data is what makes the whole mission worth it. It's how we've learned so much about places like Mars, from its ancient riverbeds to its dusty red skies. And even after years of exploring, rovers often keep sending data until they can no longer function, leaving behind a legacy of discovery. Space rovers aren't just machines. They're our explorers, our storytellers, and our connection to worlds we've never seen. Every bolt, wire, and camera is a step toward answering the biggest questions about our universe. From their first sketches to the moment they send back breathtaking images of alien landscapes, these rovers represent the best of human curiosity and determination. So the next time you see a picture from Mars or hear about a new mission, you'll know just how much effort goes into making it possible. If you enjoyed learning about these incredible machines, hit that like button and let us know which part of the process amazed you the most. And don't forget to subscribe. There's so much more to explore together.